backticks with one sentence. Second, translate the summary into French. Third, list each name in the French summary. And fourth, output a JSON object that contains the following keys: French summary and num names. And then we want it to separate the answers with line breaks. And so we add the text, which is just this paragraph. So if we run this, so as you can see, we have the summarized text, then we have the French translation, and then we have the names. Oh, that's funny, it gave the names title in French. And then we have the JSON that we requested. And now I'm going to show you another prompt to complete the same task. And in this prompt, I'm using a format that I quite like to use to kind of just specify the output structure for the model. Because as you notice in this example, this name's title is in French, which we might not necessarily want. If we were kind of passing this output, it might be a little bit difficult and kind of unpredictable. Sometimes this might say name, sometimes it might say, this French title. So in this prompt, we're kind of asking something similar. So the beginning of the prompt is the same. So we're just asking for the same steps. And then we're asking the model to use the following format. And so we've kind of just specified the exact format. So text, summary, translation, names, and output JSON. And then we start by just saying the text to summarize, or we can even just say text. And then this is the same text as before. So let's run this. So as you can see, this is the completion, and the model has used the format that we asked for. So we already gave it the text, and then it's given us the summary, the translation, the names, and the output JSON. And so this is sometimes nice because it's going to be easier to pass this with code, because it kind of has a more standardized format that you can kind of predict. And also notice that in this case, we've used angled brackets as the delimiter instead of triple backticks. You can kind of choose any delimiters that make sense to you and that makes sense to the model. Our next tactic is to instruct the model to work out its own solution before rushing to a conclusion. And again, sometimes we get better results when we kind of explicitly instruct the models to reason out its own solution before coming to a conclusion. And this is kind of the same idea that we were discussing about giving the model time to actually work things out before just kind of saying if an answer is correct or not, in the same way that a person would. So in this prompt, we're asking the model to determine if the student's solution is correct or not. So we have this math question first, and then we have the student's solution. And the student's solution is actually incorrect because they've kind of calculated the maintenance cost to be 100,000 plus 100x, but actually this should be 10x because it's only $10 per square foot, where x is the kind of size of the installation in square feet as they've defined it. So this should actually be 360x plus 100,000, not 450x. So if we run this cell, the model says the student's solution is correct. And if you just read through the student's solution, I actually just calculated this incorrectly myself, having read through this response, because it kind of looks like it's correct. If you just read this line is correct. And so the model just kind of has agreed with the student because it just kind of skim read it in the same way that I just did. And so we can fix this by instructing the model to work out its own solution first and then compare its solution to the student's solution. So let me show you a prompt to do that. And this prompt is a lot longer. So what we have in this prompt was telling the model, your task is to determine if the student's solution is correct or not. To solve the problem, do the following. First, work out your own solution to the problem. Then compare your solution to the student's solution and evaluate if the student's solution is correct or not. Don't decide if the student's solution is correct until you have done the problem yourself. Or being really clear, make sure you do the problem yourself. And so we've kind of used the same trick to use the following format. So the format will be the question, the student's solution, the actual solution, and then whether the solution agrees, yes or no, and then the student grade, correct or incorrect. And so we have the same question and the same solution as above. So now if we run this cell, so as you can see, the model actually went through and kind of did its own calculation first. And then it, got the correct answer, which was 360x plus 100,000, not 450x plus 100,000. And then when asked to compare this to the student's solution, it realizes they don't agree, and so the student was actually incorrect. This is an example of how asking the model to do a calculation itself and breaking down the task into steps to give the model more time to think can help you get more accurate responses. So next we'll talk about some of the model limitations, because I think it's really important to keep these in mind while you're kind of developing applications with large language models. So even though the language model has been exposed to a vast amount of knowledge during its training process, it has not perfectly memorized the information it's seen, and so it doesn't know the boundary of its knowledge very well. This means that it might try to answer questions about obscure topics and can make things up that sound plausible but are not actually true. And we call these fabricated ideas hallucinations. And so I'm going to show you an example of a case where the model will hallucinate something. This is an example of where the model confabulates a description of a made-up product name from a real toothbrush company. So the prompt is, tell me about Aeroglide Ultra Slim Smart Toothbrush by Boy. So if we run this, the model is going to give us a pretty realistic sounding description of a fictitious product. And the reason that this can be kind of dangerous is that this actually sounds pretty realistic. So make sure to kind of use some of the techniques that we've gone through in this notebook to try and kind of avoid this when you're building your own applications. And this is, a known weakness of the models and something that we're actively working on combating. And one additional tactic to reduce hallucinations, in the case that you want the model to kind of generate answers based on a text, is to ask the model to first find any relevant quotes from the text and then ask it to use those quotes to kind of answer questions, and kind of having a way to trace the answer back to the source document is often pretty helpful to kind of reduce these hallucinations. And that's it. You are done with the guidelines for prompting, and you're going to move on to the next video, which is going to be about the iterative prompt development process.